Thank you again. Our next speaker, Saurabh Kataria, received his PhD from Pennsylvania State University. His main focus of research is statistical machine learning applied to social media mining and link discovery. He's currently a research scientist at Xerox, where he's involved in many projects related to social media and big data.
Thank you. So the title of my talk is Social Media and Customer Care, Technical Challenges in Transformation. So basically I will talk about how social media is being ingested into whole customer care business and how it is transforming and what are the technical and research challenges in doing so. So this is the agenda of my talk. First I'll describe the business process behind social customer care. Basically customer care, taking the social input, we call it social customer care. And how an early intervention from customer care to customers is basically transforming the whole business. And after that, I'll introduce two specific research problems in that particular arena, and then I'll conclude with the remarks. So first let me tell you how enterprises are ingesting social media into their existing business process. So this was a study done by McKinsey last year, where on the x-axis you see how easy it is to capture value from social media in a particular industry, and on the y-axis how much value can you get out of it. So each bubble, the size of the bubble, represents the percentage of the US GDP. So if you, for example, if you look at the right top corner, software and internet, education and professional services, of course that's where the customer care lies in. And that's where the most potential you can get out of, including social media. So these are some business numbers. So what are the business value opportunities when you include social media? The first is that you can deepen your customer relationship. For example, in social media, you can reach out to customers directly from social media, and you can basically integrate those inputs into your operations. Second is you can drive operational excellence by making your whole process intelligent enough to take social media in. And third is you can optimize your internal workforce. For example, in this case, the customer care agents, you can basically make them intelligent enough to deal with social media or to utilize the best practices in existing operations. So how do you do that? So there is a four-stage business process to do that. First, you do a strategy. You find out what are the business hypotheses to include social media in a best way. And you can define your optimization criteria. You can define how you will achieve the success and how will you measure the success. Second is then you start listening to social media. For example, in customer care, you will start listening what are people saying about the brand, and are people having problem with the product or the customer services. And after that, you will engage with the customers through social media, or you can engage within your enterprise, or you can reach out to customers directly. And after that, you basically do a cost-value decomposition. You find out how effective your operations have become after including social media. And this is basically, we found that pretty consistent among enterprises when they use these four-stage processes, and this is what we also employ to our customer care partnerships, and basically I'll describe how that operates. So this is a traditional customer care business. Somebody is having a problem with the service, they call to customer care agent, and customer care agent basically routes to the appropriate agent to handle that problem, and that issue get resolved. Now, how social customer care comes into the picture. So basically, instead of just waiting for a customer to call, customer care agents start listening to social media and find out, is anybody having problem on social media? For example, let's say I'm using Verizon mobile, my carrier, and I'm having difficulty with the signal, and I start complaining it over social media. And customer care agents can listen to it, and they can directly respond. And if that issue can be addressed directly, they can address it. So this is what we call early intervention. You can intervene early to basically solve the issue before it cascades into a bigger issue, and it is a real problem to the customer. So again, there are 4 phases. First, you listen. In that phase, what you do is you do brand monitoring. You find issues over customer care, and after that, you basically find out what is the customer sentiment around the services. After that, once you identify issues, those you can address over social media, you route those to particular customer care agent. And after that, basically customer care agent starts engaging through social media, and over there, basically, while in the engage phase, what you can do is you can automatically track how customer care agents are performing, and you can find out how effective that status tracking is, so that you can find out the overall cost and the money that you put in business to how effective your social media inclusion is. And after that, you do the measuring. So this is where the research efforts come in, and where we can sort of, the research community can help. So there are 2 questions that we on our side addressed, and this is what I'll talk more in the research aspect. First is, can we involve communities for peer support? So as we know, a lot of people basically on social media, on blogs, basically they talk about the issues and how to solve the issues. There are well-established communities where basically people can find common issues and how to resolve those. So can we include those? Basically, can we refer a user to a particular expert within the online community? Second is, how can we measure agents' effectiveness automatically? So why do we want to measure agent effective automatically? So that basically we can, from a business perspective, the operation manager would like to find out how effective this whole social media inclusion process is. So for that, if we can find out how many issues they resolve directly on social media, and how much and how many issues they could not resolve, and those basically went to a different channel, so all those operations can help. So first, basically learning to improve agent engagement effectiveness. So basically, to solve this problem, we converted this problem into a research sequence labeling problem. So what we did was, whenever an agent have conversation with a customer, so we can basically take a look at that engagement, and we can find out the status of each and every conversation. For example, you can say that currently the issue is open, the issue has not been resolved, or you can say the issue is solved, or you can say the issue is closed. We don't know whether the problem is resolved or not, but from our end it is closed. And then is change channel. Basically, the customer care agent would ask the customer to call the customer care to have it resolved. So these are the 4 labeling basically you can put on your conversations. So after that, this is internally what we did was we turned this into a supervised classification problem, and in that problem you can, for each conversation, you can classify each and every, for example in this case, tweet or any Facebook post, into whether the issue is open or whether the issue is resolved. So yeah, these are some of the examples where you can put the label. For example, the first one is, thank you for providing your zip code. So this is basically the issue is still open, and it is. And the next line, there is an outage. Basically, the customer care agent directly says that this is a bigger issue, and basically they call it solved. So how do we solve it? So as basically is common in research field. So if you have a sequence labeling problem, conditional and random fields are the de facto standard solution for those. So what we did was, we took each interaction as our, basically the text of the interaction and all the features that you can find on social media, we took that as our features, and all the labels as conversation label. And we applied a CRF model to that. And basically first we took basically just for comparison, we took a standard data set which was published in 2000 by Co-NNL, which is a standard natural language processing test, and CRF gave around 70% accuracy on that. So in our conversational labeling task, we got around 80% accuracy, basically converting the same task in our setting. So 80% is good, but can we do more? So yeah, so basically what we can do over here is we can create an auxiliary task. what an auxiliary task would be that you look at each and every conversation and you try to assign a dialogue act label to that. A dialogue act label would be, for example, whether this is a complaint or this is a greeting or this is basically a compliment or a receipt or a acknowledgement of a solution. So how is the dialogue happening? What are the labels for those dialogues? Obviously, this is not the end task, but obviously this can basically feed us more information about the dialogue, and we can take that into account, and we can basically assign dialogue competency to each and every agent. That might be helpful. So we use basically around 12 plus label for interaction that, as you can see. So how would you label it? Again, we did the same supervised setting for this particular task. So you can see some example of labels here. For example, I am sorry to hear this, and this is apologetic. I would be more happy to assist you. This is announcement, and please send me your email. This is a request. So you can assign each and every sentence a particular task label. Now, how do you basically take this input into your learning framework? So what we did over here is that we utilized multitask learning for this particular problem. So in the diagram, for example, on the left-hand side, what you see is there is a dialogue label, which we call Z, and then again the same feature, and basically this part remains the same, and we add more label to that. So each edge represents dependency between your labels. So we formed two tasks. One is basically where we learn from feature and the interaction labels, and the other task we learn from feature and the dialogue label task. So obviously, if you combine these two, and the objective function that you get, which I'm not showing here, is convex, and you can learn it pretty well. So what we did instead was we let the framework share the parameters, and we constructed two separate tasks so that the correlation among these two tasks you can learn separately. And that actually gave us, for example, in the result section, you see, we have around 85% accuracy compared to 70% accuracy that you can get by just simply combining it. So that's where we get the improvement. On our conversation labeling task, we get around 2% accuracy by doing this, by including the dialogue task. And previously we were getting around on the dialogue task, if you don't take into account the conversation task, then you can get around 60% accuracy in this one. So yeah, so this was the first problem where we can automatically identify how agents are sort of performing in this particular setting. So now I'll shift gear, and I'll basically talk about a different problem where how we can engage experts in online communities for solving peer problems. So as we start looking at this particular problem, we identified that on the social media and in general on internet, there exist two kinds of communities. One is explicit, where people actually go and form a community for a particular objective. For example, there is a Starbucks community on Facebook that you can find. You can directly go and like this particular community, and you can be a part of the community. Another is on the right-hand side that you see is an implicit community. For example, the graph that you see is the retweet graph of retweet and interaction graph of when Hosni Mubarak, the Egypt leader, was arrested. So this is, you can see implicit communities forming around a different particular aspect of it. So yeah, so in the implicit community, it is very easy to find out what is the contribution of a particular member in that community. But in the implicit community, it is very hard to find out. So basically, we would, in our framework, we would like to treat these two communities separately. So what we did was we identified that, okay, these two communities need to be separated. So what we did was we defined a probabilistic separation between these two kind of communities. And whenever somebody interacts in a community, we assume that there is a topic in mind for that particular interaction. And user basically, whenever he talks about a particular thing, he has that topic in mind. So there are two topics. One is for community, and one is for basically just the user is talking about his particular any day activity or which is not related to community. For example, when you go and talk on Starbucks, obviously you're talking about Starbucks, and the topics will be related to coffee or some Starbucks interest. But when you are talking in general on your wall, you might be talking about your day activity. So basically, there are these separate topics that you can find out. So on the left-hand side, we took a topic modeling framework to basically solve this problem. The idea is to identify those topics which are not directly available, and we can learn it in a sort of a hidden fashion. So on the left-hand side, you see how user generation happens. Basically, what happens is this is a graphical model, and whenever a user wants to talk about a certain thing, whenever he omits a word, he has a topic in mind, which is basically his interest, not the community interest, and he omits a word. On the right-hand side, what you see is a community interest generation. So whenever somebody talks or somebody says a word, he has a community in mind that he's sharing his ideas about his community. So he picks a community, which is again hidden, we don't know about it, and he take a topic of the community's interest, and he emits a word for that. So what we did was, we combined these two using a coin mechanism. So basically what we assume here is whenever somebody wants to say a particular word, he flips a coin in his mind, and he basically, it's a biased coin, and depending upon if the coin lands head, he's going to talk about a community, or if a coin lands tail, he's going to talk about his own particular interest. So what we can get out of this particular framework is that, how much talkative you are when you talk about a community, and how much talkative you are when you talk about yourself. So we can separate these two topics out, and we can learn directly from those. So obviously, our end goal is to recommend experts in a community to a particular customer. So what we did was we created two recommendation problems. One is a peer recommendation. Basically, you want to recommend an expert for that particular issue. So you have a query user who's posting an issue about a particular problem, and so all the users that are in the community, you know their influence, you know their neighborhood similarity. Obviously, if I am going to suggest a user, I'm going to suggest in his online neighborhood. I'm not going to suggest any member who doesn't have any connection with that particular user. So we take the similarity into the account, and after that we again employ our community topic and user topic separation into the picture, and we combine these two. So this is how a user recommendation happened. Again, the same goes for community recommendation. Again, we found how important that community is, how influential that community is, which is basically probability of that community, and then after, what are the weights of user and community topics. So in the first one, we only look at the community topic. In the second one, we will take a look at both, because we want to identify if the users are also talkative in that community about community or not. So we want to take both the factors in. So this is how basically we do the recommendation. So these are, I'm not showing you the preliminary results for this. This is going to be published in paper, and I can put that. I have paper in my reference list. You can take a look. So to conclude, basically, I sort of presented how customer care is taking social media into account, and how basically they are transforming their business. And two specific technical challenges I presented. One is how to engage users in conversation, and how to basically do the conversation analysis to basically improve the agent's effectiveness. I'll take questions. Thanks.
Is there some way that in conversation analysis that you can analyze sarcastic or insincere speech?
So we have sentiment detection into the picture. So sarcasm, obviously, we are taking a look at it, but I mean, sarcasm detection is a really hard problem. And even in the sentiment section, so from the natural language processing angle, you'll be seeing that this is a positive one, but in fact it is a negative. So we are taking it.
Quick question. So here in psychiatry and community health, where they actually are looking at some very similar issues. Can we leverage social media to locate support groups within communities, after recurring support groups? And I was wondering, have you looked at any point in your, especially at any work that's going on in the health arena?
So, I personally have not, but my advisor have actually from Venture. So what they are trying to do is they are trying to look at cancer community, and where people talk about what are their health status and what are their psychological sort of state with respect to cancer. Where what people can actually support those people from psychological. So I have contacts.